Hi, in this video, we are discussing the eighth numerical from the exercise for the chapter Units and Measurements, which is the first chapter for 11th standard physics. So let's get started. Now, question में हमसे बताया गया है कि we are performing an Ohm's experiment. So सबसे पहले let us understand what happens in an Ohm's experiment. So मेरे पास एक diagram है and this actually represents the experiment. So where we have a continuous source from which we apply the voltage and then हम जो है यहाँ से current pass करवाते हैं, we make the reading of that current using an ammeter and then we also do a reading of the voltage dropped across this resistance. एंड इन दो रीडिंग्स के बेसिस पर हम इस रेजिस्टेंस का वैल्यू डिटरमाइन करने का ट्राई करते हैं. दैट्स व्हाट वी डू इन दिस एक्सपेरिमेंट. सो बेसिकली इन दिस एक्सपेरिमेंट वी कैलकुलेट द वैल्यू ऑफ द अननोन रेजिस्टेंस एंड वही हम हमारे क्वेश्चन में हमें बताया गया है कि दैट्स व्हाट वी आर डूइंग. तो वी आर कैलकुलेटिंग द वैल्यू ऑफ अननोन रेजिस्टेंस जो हम इस एक्सपेरिमेंट पे अप्लाई कर रहे हैं. सो वी डू दिस मल्टीपल टाइम्स सो दैट हमारे जो मेजरमेंट्स है उसमें एरर्स मिनिमाइज हो जाए. सो हम ऐसे मल्टीपल रीडिंग्स कर रहे हैं. सो हमने जब फर्स्ट टाइम ये एक्सपेरिमेंट कैरी आउट किया तो हमें जो रेजिस्टेंस का वैल्यू मिला दैट वाज 6.12 ओम्स. फिर हमने सेकेंड टाइम जब ये एक्सपेरिमेंट किया तब हमें रेजिस्टेंस का वैल्यू आया 6.09 ओम्स. देन वी रीडिड दिस एक्सपेरिमेंट, हमें तभी थर्ड टाइम वैल्यू आया 6.22 ओम्स एंड देन फोर्थ टाइम हमारा वैल्यू था 6.15 ओम्स. सो ऐसे 4 बार इस एक्सपेरिमेंट की रीडिंग्स हमने ली एंड हमको थोड़े थोड़े डिफरेंसेस के साथ रीडिंग्स मिली है. नाउ नेचुरल है कि इन रीडिंग्स में कुछ ना कुछ एरर्स होंगे and that's what we have to determine. We have to determine the mean absolute error, we have to determine the relative error and the percentage error involved in these measurements. And that's it. That is what the question is. We have decoded our question. Now the only part remaining is to write our solution. So सबसे पहले we start our solution by writing the given data. So let me just make the given data section. So this is given data section. And what are the quantities which are given to us in the question? Well, the only quantities, so जहाँ पर भी हमें numbers दिख रहे हैं, those are the readings. So let me say that A1 is the reading when we did the experiment for the first time. So first reading आई थी हमको 6.12 ohms. Similarly, let A2 be the second reading. तो second reading में हमारी value थी 6.09 ohms. Then let A3 be the third reading, which according to our question was 6.22 ohms. And then A4 be the last and the fourth reading, that is 6.15 ohms. So these are the 4 readings. इसके अलावा हमें question में और कुछ value नहीं दी गई है. And since no other given data is given to us in the question, now let us move on to the next part of the numerical, is to write all the quantities which we are required to find in our to find section. ठीक है. सो बड़े ही फटाफट तरीके से हम हमारा टू फाइंड सेक्शन बना लेते हैं. एंड देन व्हाट आर वी रिक्वायर्ड टू कैलकुलेट? वेल, फर्स्ट वी आर रिक्वायर्ड टू कैलकुलेट द मीन ऑफ एब्सोल्यूट एरर. सो हर एक क्वांटिटीज में कुछ ना कुछ एब्सोल्यूट एरर होगा और उन चारों क्वांटिटीज के एरर्स का मीन या एवरेज हमें ढूंढना है. सो मीन ऑफ एब्सोल्यूट एरर and we have decided to represent this quantity as delta A, which is the absolute error, but since it's mean, I'm going to write it as delta A mean. So absolute error in the readings का average निकालना है. What is the second quantity which we are required to calculate? Well, we are required to calculate the relative error involved in the readings. So relative error भी हमें जो है वो ढूंढना है. And then the third quantity जो हमें ढूंढना है, that is the percentage error involved in the measurements. Percentage error involved in the measurement. So these are the 3 quantities as per our question जो हमें ढूंढना है, relative, percentage and the mean absolute error. इसके अलावा और कई quantities हमें question में नहीं पूछी गई है. So now let us discuss what sort of formulas we can use to calculate all these quantities using the given data that's been given to us. And we'll discuss these formulas in our formula section. So we have quickly crafted our formula section. So let's get started. सबसे पहले हमारा टास्क है टू कैलकुलेट द मीन एब्सोल्यूट एरर, जो आप स्क्रीन पर देख सकते हो. बट मीन एब्सोल्यूट एरर का फॉर्मूला requires us to calculate absolute errors of each of these quantities first. ठीक है, तो हमें A1 का एब्सोल्यूट एरर, A2 का, A3 का एंड A4 का. And in order to calculate absolute error of each of these readings, we need to first find the mean, that is the average of all of these readings. So सबसे पहला task would be to calculate the average of these readings. So I am going to represent mean of readings as a mean. So this is the average of all the four readings, and average calculation is pretty easy. We do summation of all the readings, that is a1 plus a2 plus a3 plus a4, and we divide it by the total number of readings, which in this case is 4. So over here we are calculating the mean of our readings. So we are calculating mean of readings. Okay, now the next step is to calculate the absolute errors for each of the readings. And uska jo formula hai, that is, if I have to calculate absolute error for, let's say, first reading or second reading or third reading. So general formula is delta of a n is equal to mod of a of mean. So basically mean reading minus the desired reading. If we are calculating error for first reading, so minus the first reading, उससे हमको जो है एब्सोल्यूट एरर इन रीडिंग्स मिल जाएगा. सो दिस इज द जनरल फॉर्मूला फॉर कैलकुलेटिंग द एब्सोल्यूट एरर. And now, once we calculate the absolute error for all the four instances or all the four readings, we can now calculate the mean of those error. We represent it using delta A of mean. So that is simply addition of all the absolute errors. So हमारे पास four readings है. So we'll be calculating absolute error for reading 1, then reading 2, then absolute error for reading 3, and then absolute error for reading 4. And to average out, we'll divide it by the total number of readings, that is 4. So ऐसे हमें जो है हमारा जो first task था, that is to calculate mean absolute error, that is our first requirement, हमको इस formula से मिल जाएगा. Now we need to figure out ways to calculate relative errors and percentage error, which will be using the definitions of relative errors. So उनके definitions में ही उनके formulas है. So as per the definition, relative error is given to us as, so relative error is given to us as delta of a mean, so mean of absolute error divided by the mean reading. So this is the relative error as per its definition, and then we'll use the definition of percentage error to calculate percentage error as well. इन दोनों quantities के definition में ही इनके formulas है. So percentage error is basically relative error. So हम जो भी relative error ढूंढेंगे into 100, which is expressed. So this error is actually expressed in percentage. So I'll quickly just make a small note, expressed in percentage. Okay, so now that we have written all the formulas which will be required, the only thing remaining is now to actually solve, substitute the values and solve these formulas. So I'll quickly prepare our solution section for our numerical. So in our solution section, we'll say the first step from our formula list is to calculate the mean of all the readings. So I can say from formula 1, let's calculate the mean of all the readings. So mean of all the readings, so that is a mean, which we are representing. So that is addition of all the readings divided by the number of readings, which is 4 in this case. So our first reading, that is A1, is 6.12, and A2 is 6.09, A3 is 6.22, and A4 is 6.15. So from the formula 1, that is formula 1, we all have to substitute this value. So it is 6.12 plus 6.09 plus 6.22 plus 6.15. And if we were to solve this further, if we were to add all the terms in the numerator, the addition would result in 24.58 divided by 4. And if we were to further simplify or solve this particular expression, our mean reading would come out to be 6.145, A of mean. Okay, now since all the values which were given to us is in ohms, so A of mean should also be in ohms. So the mean reading of the resistance is 6.145 ohms. Okay. And with this, we have actually calculated our first task, that was to calculate the mean of the readings. Now let us use this to calculate the absolute errors involved in all the readings. So I can say from formula 2. So let me just use my ink. So from formula 2, let's calculate all the absolute errors for each of the readings. So first step is to calculate the absolute error in reading 1. So it would be mod of A of mean, which is 6.145. Let me just mark this equation as equation 1 so that we can refer to it, minus the reading of A1, which is 6.12. And if we were to solve this, we get the answer as 0.025. Okay. Now let's calculate the absolute error for reading 2, which will be mod of mean reading, that is 6.145, which we just calculated, minus the reading of A2, which is 6.09. And in this case, the absolute error comes out to be 0.055. Now let us quickly calculate the absolute error for third reading, that is mean, that is 6.145 minus 6.22, that is the reading in the third measurement, and that came out to be minus of 0.75, because as you can see 6.145 is less than 6.22, but since we are doing the operation under a mod, so whatever the resultant value is, it always gets converted to a positive value, so that's why it is positive 0.75. Now let us move on to calculate the final absolute error, that is the absolute error for the final reading, that is delta A4, that is mod of mean reading 6.145 minus the reading for in the fourth attempt, that was 6.15. And if you were to solve this, we get the error as 0.005. So these are all the errors involved in the readings. So error for the first reading, that is delta A1, is 0.025. Error involved for the second reading is 0.055. Third reading is 0.075, and error involved in the fourth reading is 0.005. Now we'll use all these four readings to calculate a mean of these readings, and that will give us the first value which we were required to calculate, that is the mean of all the absolute errors. So let us quickly use the formula. So I can say from formula 3, because that's where we discussed the condition for calculating mean of all the absolute errors. So from formula 3, let us quickly refer what is our formula 3. Well, our formula 3 is delta A of mean is equal to addition of all the errors. So I can say, let me use a different ink. So mean of absolute errors is addition of all the absolute errors. So first absolute error, that is delta A1, is 0.025, plus second absolute error, that is 0.055, plus the third absolute error, that is 0.075, plus the fourth absolute error, that is the error in the fourth reading, that is 0.005, divide by the total number of readings, which is 4 in this case. Okay. Now if we were to add all the numerators, we would get the value as 0.160 divided by 4, which comes out to be 0.04 ohms, since all the readings are in ohms because we are measuring the unknown resistances. So error involved, so mean of absolute error involved in this measurement is 0.04 ohms, which is the first value which we were required to calculate in this particular numerical. So we are done with our first value. Now let's move on to calculating the relative error. So as per the formula of relative error, all we have to do is to divide the mean of absolute error by the mean reading, and we get the relative error. So I can simply say from formula 4 this time, we get the value of relative error. So I can say relative error is equal to delta A mean. The value of mean of absolute error, that is delta A mean, is 0.04 divided by the mean reading, which we calculated long back. So that is over here, that is 6.145. So divided by the mean reading, that is 6.145. And if you were to solve this, our relative error comes out to be 0.0065 ohms. So that is the value of the relative error. So again, I say therefore our relative error is 6.5 into 10 raised to minus 3 ohms. So with this, we have calculated the second value which we were required to calculate. That is the relative error. And now all that's left is to calculate the percentage error, and we'll be done with our numerical. So what was the formula to calculate percentage error? Well, we simply have to multiply relative error with 100. So let us do that. So from formula 5 this time. So from formula 5, we can say percentage error is equal to 6.5 into 10 raised to minus 3. This is my relative error into 100. Now, if I were to solve it further, it would be 6.5 into 10 raised to minus 3 into 100 becomes 10 raised to minus 1. And let me just write it in decimal form. So it will be 0.65%. So this is our percentage error involved in the measurements. So percentage error. And this was the last part of our numerical, that was to calculate the percentage error. From this, we can build a final statement stating that the mean of absolute error is 0.04 ohms. The relative error is 6.5 into 10 raised to minus 3 ohms, or 0.0065 ohms, and the percentage error is 0.65% because it's a percentage error. With this, the solution is done. If you want a PDF of the solution, make sure you check the description. I hope it helped you. Thank you.